In this problem, we want to find the effective resistance between the points A and B. And if you look at the problem, the other end of the problem is infinite. That means there are infinite resistors in the problem. So generally, whenever there is a problem with finite resistors, we'll start solving the problem from the other end and come to the points A and B where you want to find a resistance. But unfortunately, this problem is having infinite resistors. Then how to solve the problem? We cannot solve it in a conventional way. So if you look little carefully, there is a kind of a pattern repeated in this problem. See this? This is R and this is 2R. This is a pattern. You can see here again R and 2R. You can see here R and 2R. So one simple thing that you can notice is this is the pattern that got repeated throughout the problem up to infinite resistors, up to infinite. So let this entire circuit is having some resistance X, which we have to find out. That X is having a summation of infinite patterns like this, infinite symmetries like this. As it is having infinite symmetries, excluding one symmetry just to solve the problem is not going to make any difference to the problem. So I will just exclude the first symmetry, that is this one, and I will assume that the entire remaining resistance is equal to X. Because this is of infinite systems, I have just excluded one, the answer shall not make any big difference. So let us redraw the circuit again. A, resistance R, resistance 2R, B. Instead of the entire remaining circuit, I will write only one resistance, that is X. That's what we have to find out. For this X, we have just added only one more symmetrical value of R and 2R, but practically it shall not make any difference. So the answer is again equal to X. For X, who is a combination of infinite symmetries, adding one more symmetry shall not make any difference. So the answer is still equal to X. But if you look little carefully, this 2R and this X, these two are parallel. See, these two ends of the resistors as well as these two ends of the resistors are connected. So whenever the resistors are in parallel, we know there is a formula. R parallel is equal to R1 R2 by R1 plus R2. You must have known this formula. If not, I will just add a link here where you will know how to find out the effective resistance when the resistors are connected in parallel, and I will add a link in the description also for your convenience. Yeah, let's use that formula now. R1 is 2R, R2 is X. So R1 R2 means 2R into X by R1 plus R2 is 2R plus X. So if I redraw the circuit will change now. A, R is there, A, R is there, B. Instead of these two, we have found one value, that is resistance parallel, that is this value. How much is that? 2R and X by 2R plus X. Now if you look at these 2 points A and B, here if you connect a battery between these 2 points A and B, though it was not shown in the circuit, I will show it to you for your convenience. This is like a battery. This is how a circuit is connected. So from here a current starts, that will go like this. It will go through this R, it will go through the remaining resistance, comes back to the B. As the same current is passing across that elements, we can clearly say this resistance and this resistance are in series. We know again R series as R1 plus R2. You have learned this already in this lesson itself. So the entire effective resistance between the points A and B is these two resistors are in series. So R1 plus R2. R2 is 2R and X by 2R plus X. This entire resistance between the points A and B, as we have done in the previous step, is again equal to X. Now we know how to solve the problem. Yes, by simplifying this equation, 2r plus x is the LCM. Let us take that LCM. Let us solve this equation. R of this is 1, so we shall multiply with 2r plus x. This is 2r plus x, therefore we shall multiply with 1, that will be 2r into x. That's equal to x. Hope you are following, right? This is little carefully we shall follow this problem. Then x is equal to, let us simplify, r into 2r, that is 2r square, plus r into x, rx, and then 2rx divided by this value, 2r plus x is equal to x, like this. Then 2r square, 2rx and rx, 3rx equal to, let us take this term to this side, x of 2r and x. So 2r square plus 3rx is equal to 2r into x into x is x square. So let us take this left side terms to the right side, 2rx, this term, plus x square. This is going to other side, therefore minus 3rx minus 2r square on the other side equal to 0. So the equation will be like x square plus minus 3rx plus 2rx is minus rx. This is minus, because this is minus 3rx, this is plus 2rx, minus 2r square equal to 0. So we have got a two-dimensional equation. You know, this is like ax square plus bx plus c equal to 0, a general equation. You have learned in the school, for this general equation solution, x is equal to minus b plus or minus b square minus 4ac by 2a. Just applying that to this case, to this equation we shall find a solution, ax square. So in the place of a, there is only an x. Bx, in the place of b, we are having a minus r because this is plus bx. In the place of c, we are having a minus 2r square because this is a plus c. So minus b means minus r here. So minus of minus r plus r minus b square, that is minus r whole square minus 4, a is 1, c is minus 2r square by 2a. A is again equal to 1. So that implies value of x is equal to minus of minus r is r plus r minus r whole square is r square. This minus into minus is plus, that is 8r square by 2. That implies r plus r minus r square plus 8r square, 9r square by 2. Let me just take to the next column. Yeah. So a value of that x, that's the resistance between the points A and B, is r plus r minus root of 9r square. Square root of 9 is 3. Square root of r square is r. So there are two possibilities here because we are having a plus as well as a minus. So the possibility of the x is either r plus 3r by 2. First term, r minus 3r by 2 because there is a plus r minus here. Observe carefully, this is plus r minus. So it could be possibly a value of plus or it could be a value of minus. But if you see little carefully, this is r minus 3r, that is, so the values will be r plus 3r, 4r by 2, x value. Our x value could be r minus 3r minus 2r by 2. That implies the possible value of the x is either 2R or minus R. Negative value is ruled out because we are connecting so many resistors, it's not going to give a negative value. So as negative value is ruled out, as resistance can't be negative, resistance between the points A and B, that is X, is nothing but equal to 2R. That's what your answer is. Finally we got the answer. But I want you to observe one thing. You have connected infinite resistors in the problem between the points A and B because the other end is infinite, but still the answer is a finite answer. X is nothing but equal to 2R. That's it.